I'm going to pretty much carry on from where we left off the other day. I should also say I'm sorry if I offended anybody by talking about leading and lagging, as that those are not the best choice of words. Because from my point of view, leading really means experimentation, which is not necessarily a good thing. In other words, as I said, the Bay Area might be leading in the sense that they're doing all this experimentation, but 90% of those experiments fail spectacularly. Right? It's exciting, but nuclear wars are exciting in some way, and that just because it's exciting doesn't mean that I want to be there. So there's something to be said for waiting a little bit conservatively for things to shake out a bit and see what is worthwhile and what is not worthwhile, and how did that work out for you? That's a really good question, right? And if you are just plain experimenting, you don't know yet, right? So it's a different world than most of the rest of the planet. So there's a natural tendency to want to find out what people are doing out there, but bear in mind that 90% of what people are doing is going to fail. So don't take it with too seriously at first. Is that wait? I'm a firm believer in letting things settle down. You know, when I do back ends by choice, I do them in Java, which makes me a hopeless conservative as far as the Bay Area is concerned. In the Bay Area, Java is a boring language. It's been around too long, and nobody wants to program in it anymore. So there we go. The other thing I want to point out just came up in a conversation up here that I think that's also worth thinking about is that the main reason that that effect happens in the Bay Area is because there is such a high percentage of startups, and startups are very cost aware. Microsoft is kind of in the position that IBM was in many years ago, where their stuff is pretty solid, but it's also pretty expensive. Is the cost per developer for a full-blown workstation, development workstation with a SQL Server license and you know, all the licenses that you need, that can get up into the thousands of pounds, and that's, for a startup, they just can't afford that. It just costs too much. And you go to open source stuff because the cost is free. And there are both advantages and disadvantages to that. Is that the open source stuff, some of it is pretty solid. Certainly Apache is solid. Certainly Eclipse is solid. And certainly Git, things like that are solid. But you start getting into some of the other technology and it's dicier. Is that it may or may not work the way it's supposed to, and you're trading off upfront costs for down the line costs maybe, but that is something that matters to the startup equation. So if you're not doing a startup, the situation is completely different, of course. And you make decisions for other reasons. If you actually have revenue, you're in a much better position than if you don't. So as I said, it's a different world. The focus is different. If you're doing corporate stuff where quality is important and that kind of stuff, you tend to go towards well-known, well-trusted solutions, and there's nothing at all wrong with that. As I would be really annoyed if my bank decided to rewrite all of its software in Haskell because somebody thought it was cool, right? It's not a good strategy, let's put it that way. So the situation depends on the world that you're in. So my agenda for the next 90 minutes or so is to, as I said, carry on from where I was last time. And by that I mean I'm going to talk a little bit about the accessor mutator problem. I'm going to talk about the fragile base class problem, and I'm going to talk about the process that one uses in the Agile world to go from a story through to a design, or at least as much of a design as one has in an Agile environment, just so you can see how that connection is made. And these topics are all actually related, because it turns out that when you go through a story-based design process, you tend to not have accessors and mutators in your code because they just never appear. They never come up. And the same thing happens with very deep class hierarchies, is all of the problems that are associated with fragile base classes. You tend to not see them because you tend not to have many base classes, as the hierarchies, when you go through it, starting at the story, tend to be very, very flat. If anything, there may be two layers where you have an implementation layer and an interface layer above it, but it's rare to see real extension, real derivation, real subclassing and superclassing when you're approaching the design from the story as your main impetus. So all three of these topics are actually quite closely related to each other. So here's our guy being extended, but let's start where we were. Right, this notion of the ISA test. I talked about the ISA test. But the first question with respect to inheritance is, I'm going to talk a lot about fragile base classes momentarily, but the first question is, do you even want a base class? is how do you make the decision about whether inheritance should be there or not? And ISA works with respect to talking about things. A manager is an employee. But a manager is not an employee unless it is an employee in every sense. But if it's just an employee in every sense but is categorized differently, then there's no extends relationship. Because then you just have some employees in one list and other employees in another list. So ISA is not working here. I can say ISA, but that doesn't mean that, it means exactly, is exactly. And if it is exactly the same thing, then it's the same class, it's not an extension. So the second option is that, again, I mentioned this a little bit the other day, but it bears repeating, is that this notion of authorizing a timesheet versus filling out a timesheet. The issue there is, again, these are completely distinct roles inside the application with no overlap. And I'll talk more about this in about 20 minutes or 30 minutes, but the role that somebody takes on within an activity is what you're modeling. You're not modeling the actual person or the person's job description, right? The fact that a manager is an employee in the real world, in a sense, does not matter when you get down to the modeling level. Is that what matters is the role, is what they do. So if a manager is in one role and one role only within the program, then you're going to model what the manager does in that role, and that's all you're going to model. And the same goes with a generic employee. If they're in the program in only one role that an employee has, in this case, the employee's entire responsibility is to fill out a timesheet, then that's all that you're going to model. So again, there won't be any connection. So you shouldn't go there first. Shouldn't be an automatic, a manager is an employee, therefore there's a derivation, is that it's something that you would add much later only when you discovered you needed it. The initial assumption would be that there was no connection. And then there's the third situation, which is real inheritance, where the manager does a little bit more than a normal employee. So that one is the one that's real. That's the one that you actually want to be using extends in. But that's the only one. So often then, the way that base classes come into a system is through a kind of normalization process. In other words, what you're doing is looking at code that has developed spontaneously over the course of the Agile process. And you look at that code and you say, well, I see these two classes seem to be doing the same thing. They both have export operations. And is that really the same thing? And more often than not, it is. As you look at the two export functions, and more often than not, if they're not identical, they're close to it. Now, of course, if something is close to something else, it's easy to customize it using things that are in all of our languages. In other words, if you're programming in C#, you have lambdas and delegates to work with. And if you leverage that properly, then you can make a relatively solid but somewhat more generic export method and customize it on an as-needed basis by passing the correct delegate in. Java has lambda functions as of Java 8. So that's a problem. It's been a problem with Java for years that they weren't in there, is that it has annoyed me. And finally, it's actually in the language, but Java 8 is not really accepted yet because it hasn't been integrated into the development tools yet. Eclipse doesn't support Java 8 yet. But it is available. If you want to fiddle around with it, you can download a perfectly functional version of the Java 8 compiler from Sun and write in VI or Emacs. Right? There's a religious war for you, whether you're going to write in VI or Emacs. But it's in the language finally. So what that means is that we can introduce another class whose job is to export stuff. I said executor. I should have said exporter. That's actually that's a typo on my case. But the notion then is that I'm doing normalization, is that I'm getting rid of duplication within the class hierarchy by using an inheritance mechanism. Now, in both C# and Java, there's limits to what we can do here because we can only have one true base class in both languages. And so you may or may not be able to actually use inheritance as a normalization mechanism, because if you had to pull three things out into three different base classes, the languages just don't support that. In C++, of course, you have the options. So in that situation, you use an interface instead. So now exportable is turned into an interface, and the export is up there. But we then have to implement it in the two derived classes. Now, I should have added a fourth view here, which I didn't, but there's one on one of the slides that's going to come up shortly. But the issue there is that even though export shows up in both of the classes, that does not mean that the implementation has to be in both classes. In other words, there can be a helper utility that actually implements export in order to get the code in one place. And then both class 1 and class 2 could use the common helper utility. So that's better in a sense. Implement an interface and use a helper. And the advantage of that is that in C# and in Java both, you can implement as many interfaces as you want. So we have polymorphism in the sense that I can write things in terms of the interfaces, which is really why we would be using inheritance anyway. And at the same time, we have the advantage of having the class in one place because we have a helper class that has a single implementation in it. So I'll show you an example of that in a moment. But that's what I'm doing here, if you haven't noticed, is I'm talking myself out of using inheritance. I'm talking myself out of using some kind of extends relationship. And let's talk about why. Is that the problem here is something known as the fragile base class problem. Fragile base classes are kind of scary. Is that it's something that people tend to not think about, and it is something that we need to think about every time inheritance is on the picture. The problem here is that derived classes depend on base class functionality. They depend on the base classes behaving in a certain way. And I mentioned a lot yesterday that that's a really bad thing, is that classes shouldn't be based on knowing how some other class works, is that the behavior should be independent as much as possible. And that applies to base classes and derived classes or subclasses and superclasses just as much as it does any other classes, is that a subclass should not know how the superclass works. And there are a lot of ramifications there. Among other things, it means that protected is a really bad thing, because if you're using protected variables, at least protected fields, you are exposing information about how the base class works, which means that you cannot modify those base class things. And that could be a big deal in a library that depends on extension, because the base class might be part of the library and the extensions might be part of your application. And there might be 100 applications, all of which depend on the base classes which are in the library, which means that your hands are tied. You cannot change something in that library because it's going to impact 100 different applications, and you don't have control over those 100 applications. You can't test, in other words, what happens when you make your change. So that's really an untenable situation from an Agile point of view, that you can't touch something because you're touching the classes all the time. So that's one significant issue. But the worse issue is that if you depend a little bit on knowing how the base class works, you can end up in a situation where somebody improves base class behavior, but nonetheless breaks all the subclasses, nonetheless breaks all the derived classes, which is what a fragile base class is. So let's see how that actually plays out. This is not quite a fragile base class yet, but it's got problems. So I wanted to start with one set of problems and then move into another set of problems as we evolve forward. Right, so here I showed you a picture of this the other day, but here's some code, right? We have a stack that extends array list. That, as we saw when we were talking about the solid principles, was an incorrect decision. A stack is not an array list. An array list can do things that stacks cannot do. Array list can have a add head, for example, and at no point does it make any sense to add something to the head of a stack. So saying a stack is an array list is actually incorrect. But putting that aside, there are problems that have to do with how things will work as you move forward with this kind of arrangement. So here I have a push operation, and here I have a push many operation, where push many is calling push multiple times. Is everyone following me? This is a real world problem, by the way. It doesn't happen to be a problem in Java's stack class, but it is a problem in Java's input stream class, which is an abstract base class. It's not an interface, and it has exactly this problem. All right, so we have one method calling another method at the superclass level. So what's wrong with that? Well, what if you leverage that information? First of all, what if you leverage inheritance? This is bad for the reasons that we talked about the other day, right? Is that the stack pointer, going back to the previous slide, that stack pointer is in the stack class. It's not in the array list, and the stack pointer is being modified by the push and pop methods. So if I say clear, I'm clearing out the base class set of things that are on the stack, base class items, but I'm not changing the derived class at all, which means the next time I try and pop, I'm going to get an exception thrown because that element won't exist anymore. So is everyone following what I'm saying? So this is not a fragile base class, but this is pretty fragile. This is not a situation that you want to have around where something perfectly reasonable happens. But nonetheless, something breaks. In other words, you can't use the derived class as a base class. Does anyone remember what the name of that solid principle was? At a conference like this, it's interesting because you're cramming so much stuff into your head that everything just flies out the other side. But this is the Liskov substitution principle that we're talking about, this notion of you must be able to treat a subclass object as if it were a superclass object in all contexts. And you can't do that here. Right, so. What about encapsulating? That helps. That gets us in, it moves us in the right direction. Right, so now instead of extending array list, what I'm doing is using an array list. And that puts us in a much better shape from a maintenance point of view. For one thing, there's a push and a pop, but if you pass a stack to somebody, they can't say clear because there is no clear method in the stack class anymore. Is everyone with me here? So this seems okay for the moment, is that we have a stack pointer, it's in the stack class, but the stack class implements a push and a pop and a push many, and it doesn't implement anything else, so we are saved from the problems that would come up from implementing something else. But what if we decide to change our stack class a little bit? Here's a new version. What I've done is I've added a high watermark. The purpose of a high watermark is to tell the maximum stack size at runtime, which is kind of it's a handy metric to have around when you're testing. So every time you push something, if you push more things than have ever been pushed before, you update the high watermark in order to indicate that you've pushed an extra item. And every time you pop something, well, you don't have to do anything for a pop. And then there's a maximum size so far that we had it. Now, the thing to notice here is that we have a new method, but we're missing push many, because that's being inherited from the stack class. Right? It didn't occur to me to override push many because I've solved all the problems I need to solve here in the methods that I have provided overrides for. Is everyone following me here? And push many will work. So my tests will pass here because push many is going to call the derived class versions, and that's fine. Now, what if I decide to improve the quality of the base class? Some maintenance programmer looks at the stack definition, which remember is in a library. They might not see the stack that I just created. They might not know that that class even exists. And they look at the stack class in the library and they say, calling push multiple times, that's nuts. Let's just do an efficient block transfer. So they make this change. All right, so everyone with me so far? They've improved the quality of the class, and at the stack level, all of the unit tests pass. At the monitorable stack level, they may or may not pass, but the guy who just made this change doesn't know that that class even exists and certainly doesn't have access to those tests. So we end up in the world where we have this problem. I create a monitorable stack, I say push many, and then I ask for the maximum size. What number am I going to get here? Does anybody know? 0, big 0. Right? Because push many is no longer calling push. So the maximum size, the watermark, is never incremented. So if you're not looking like this at this point, you should be. This is scary. Is that what it means is that you have a situation where somebody made a completely legitimate change to the base class. Improved it, in fact. And they were diligent about testing, and they passed all their unit tests. Everything seems fine, and nonetheless, the derived class methods break. This is not a good position to be in. Is everyone seeing what my point is here? So, there are other variations on this theme, right? In other words, here I've got a base class, a superclass that's got a caller and a called method in it. And then here I have a subclass that overrides the called method. Now notice that the original version of the called method is modifying the state of the superclass. Notice that my override is not, right? In other words, this guy is changing something. And this guy expects that that change has happened. And this guy is not changing anything. Right now, the rule here should be, in this situation, the subclass override should have called the base class version. But is that going to happen? I don't know, maybe. If you remember, it's not a hard rule. It's not something you want to do all the time, so it depends on context. You could put it in the documentation, and the person who's writing this code may or may not read that documentation. This is very dangerous. So this is another kind of fragility. I think it's a little bit better, I guess, than the original fragility, because at least I could get some exception tosses in here that would tell me that something was wrong. But I don't like runtime errors. I really like errors to be at compile time, not at runtime, if at all possible. And so having an exception thrown is cold comfort. It's particularly if that exception is thrown while the server is actually running and in production. So I want things to be solved in the real world. So the color is really broken here. Okay, is everyone with me here? So how can we fix it? First of all, I'm going to introduce an interface. So the stack interface shows me what stacks should be working like. And then I'm going to rename my old stack, monitorable stack to simple stack. Or actually, my old stack class rather to simple stack. Is everyone following me here? In other words, I introduced a new interface, and then I renamed stack to simple stack, and then I make my simple stack implement the interface. And I'm more or less back where I started. And some of our development tools will do this particular refactor for us automatically. So simple stack is where it belongs, but now we have other options. Now monitorable stack can implement the stack interface instead of overriding, instead of extending. And now it's using a simple stack, and now it has to provide a push many at this level. We have no choice. It's in the interface. And push many can be implemented in terms of the other methods that exist in the class, but we have to implement it. So what's happening here is the compiler is forcing us to do what we should have done originally, which was override high watermark. So everyone following my rationale? So it's up. Did I hear a question? No. So it's because we're using the interface that makes this work, right? Because we're using an interface, we can delegate rather than just inherit functionality. But more importantly, we're forced to implement push many. Okay, which is also delegating, you'll notice. Mm-hmm. Right.
So what's stopping you making the same assumption and simply delegating push many down in simple stack?
Because now you would not expect push many in the stack object to be calling push in the monitorable stack object, and before you were. Right. In other words, you've eliminated the possibility of the bug happening. Okay. To go through my build here. There. So this gives us a design pattern. This one doesn't have a name as far as I know because it's right on the edge of being an idiom, somewhere in between being a design pattern and being an idiom, but it's certainly a solution to this problem that occurs all over the place in lots of code that's developed independently by lots of people. And the basic idea is that any time you are using extends, you can replace that with an interface and a uses. All instances of extends can be replaced with an interface and a delegation relationship. And that's an important thing to bear in mind. You don't have to use extension anyway. Again, I've talked about Microsoft and some of their bad architecture, but The original COM architecture is a spectacularly good architecture. And it did this. And people grumbled. And Microsoft reluctantly knuckled under to the grumbles and added inheritance to COM, and they never should have done that. Right? People were screaming that, I don't want to do everything through delegation and interfaces. Right? I want to inherit from a base class. And that was, I think, the wrong decision. And I've talked to friends that work at Microsoft who agree with me, right? We never should have done that, right? And the customer isn't always right. Sometimes the customer doesn't know what's good for them. And in this case, the customer was definitely wrong. So there are languages that only support this inheritance model, an interface and delegation inheritance model, and I think that's a good thing. And frankly, even if we're programming in C++ or Java or C#, I think we should be following this pattern rather than using extends relationship whenever possible, because it eliminates that fragile base class issue. And fragile base classes can be notoriously difficult to track down. And the problems can occur only occasionally, and they end up with exceptions happening at runtime that we're not expecting. And they're hard to test for, is that generally speaking, if you can avoid it at the compiler level, you're much better off. All right, now the other problem that I wanted to talk about generally is accessors and mutators. That was an accessor we just saw. He's accessed the back of the wall. This is a great movie, by the way, if you haven't seen this. This is Mel Brooks's Young Frankenstein. It's worth renting on Netflix and watching. It's one of the world's funniest movies. At least if you've seen the original Frankenstein movies, it's one of the world's funniest movies. But, and then we have our transmogrifier, Calvin's transmogrifier, is that turns things into other things, right? The notion of mutation, right? What a lot of people don't know is that transmogrifier means turn into a monster. And that's often what's happening when we're doing something that we think of as transmutation. It's actually transmogrification, is that we're not turning lead into gold. We're turning normal animals into monsters, which is not a good thing to be doing here. So let's look, first of all, at what the basic problem is. So I'm going to give you guys an exercise. Those of you that were in the design patterns class a couple days ago have seen this, but so I will apologize to you guys, but we weren't all there, were we? How many people were in that class, just so I have a feel? Oh, nobody was, or a handful of you were. Okay, so you guys can consider this to be reviewed. For the rest of you, here I have an example that's out of every basic book on object-oriented design that you've ever read. Right, the classic shape class from which you extend circle and line and square, right? Every book on the planet uses this to explain polymorphism. So I'm going to give you a challenge, though, and this is something that none of those books ever talk about. And the challenge is, I want to be able to modify that base class without impacting the derived classes for all of the reasons we were just looking at. Is everyone with me here? And the shape class has legitimate attributes and legitimate operations. Right? The line color belongs in the shape class because all derived classes, all extensions have a line color. Right? And there are operations that make sense, like darken, right? Darken the current line. So it's quite legitimate for there to be shapes for there to be methods up there. But then there's that abstract draw method, and all the books will tell you what you want to do is override draw so that a circle can draw a circle and a line can draw a line and a square can draw a square. Is everyone with me here? Now, the problem with this is how are we going to implement draw? In other words, you look at that comment there and there's that set color call. Well, there has to be then, you would think, a get color and a set color up at the base class in order to be implementing the set color underneath. Is everyone following me here? So you think, I have to have a getter setter. I have to have an accessor and a mutator. The problem with that strategy is that if I need to update the shape class, let's say, for example, I want to add a line thickness. I have to have now a get thickness and a set thickness so that I can set the line thickness down in the derived class. Is everyone with me? So there's two issues. First of all, I've added a whole bunch of complexity. I now have 4 methods: get color, get thickness, set thickness. And I'm going to have to add 2 more methods every time I add a capability at the base class level. So the base class is getting pretty big. And those methods all have to be tested, and those methods all might interact with each other, right? And big is bad. The other problem, though, which I think is a more significant one, is that if I add a capability at the base class level, I am forced to modify the code in every subclass in order to be able to leverage that capability. That's the worst problem. Is everyone with me here? So my challenge to you is, how do I fix that? How do I eliminate that problem? And that's a real question. I want to hear an answer. And I can hold out longer than you can. A modify shape class that was separate. That's even more complicated. So yeah, it would work, but I don't want to add complexity, I want to remove it. All right, so my goal here is to make things simpler as possible. Okay, I can hear. A set proxy. So what does that mean to you? I don't understand the term. Oh, a set property. But that's just a set. Right? We'll talk about properties in a second, but properties are not helpful here. I'm not a big fan of properties. There's a lot in C# that I like, but properties is not one of the things that I like. Okay, think about one of the things that I was talking about the other day, which is an important issue here, is that remember that notion that the thing that has the data should do the work. Ask for help, not for information. And that rather than getting the data that you need to do something, you should ask the object that has that data to do the work for you. Who has the data here? The base class, the shape. Who needs the work done? The derived class, the circle, the line. Right? So using that principle, what that's saying is that if the line needs the color to be set, it would delegate to who? To the shape. So what's solution number 1 then? Well, or at least a method that will do that. I'll put up a setup method up there. All right, is everyone following me so far? So this is pure delegation. This is better. This is not optimal yet, but it's better. Is everyone understanding where I'm getting here? Now notice that once I have done that setup graphics, I can remove the set color and the get color. And notice once I have that setup graphics, I don't care about the fact that I've added a line thickness. At least I don't care at the line level. Because when setup sets up the graphics, it will set up both the color and the line thickness. I can add as many attributes as I want, and the lines and the circles of the world don't care. So I'm in a much better position from a maintenance point of view. Much better. Everything about this is better. I can modify the shape class without impacting the subclasses. I have eliminated a significant number of methods from the base class. I do not need those getters and setters anymore because there's nothing that they would do. So everyone following me here? So putting aside the getter and setter evil issue, here I've just improved the quality of the code by eliminating the gets and sets. Is everyone with me here? Now let's take it a step further though. If you're anything like me, you're going to forget to call setup at least 20% of the time, right? I will happily admit that I'm not the perfect programmer. I said that in a book once. It was hilarious. I wrote this huge book on compiler design years ago. It was like a 900-page book on compiler design. And it was reviewed by this guy at Princeton. And he hit on, I had a sentence like the one I just said. You know, if you're anything like me, you're going to forget to do this. And one of his comments, in big boldface, was, I would never admit that you would forget to do something in print. And I'm going, there's the difference between the real world and academia. The academic says, oh, I never do anything wrong. I don't make mistakes. I'm sorry. We should be programming defensively, and who we're defending ourselves against is ourselves. So I know I look at this and I go, I'm going to forget to call it. This isn't good enough. So how could I eliminate that problem? How could I solve the problem of forgetting to call setup? I want to set things up, in other words, so that the circle and line classes don't have to call setup anymore. All right, well, think about what we were talking about yesterday. One of the other solid principles is the dependencies in this direction are inverted. They're going in the wrong direction. In other words, line is dependent on the shape. And I don't want it to be, is that the whole point of this exercise is to eliminate those dependencies, but I still have this dependency left. Right? Now, if you can remember from yesterday, the way that we solved the dependency inversion problem was by introducing an interface. But in this case, we don't have to go to that extreme. We can just introduce an abstract method. So here's the solution, my solution to that problem. Is what I've done is I've turned draw into a real method. It's not abstract anymore. It exists up in the base class. There's no need, in other words, there's no need to use polymorphism here. People go to polymorphism because they've read it in the books that it's a good thing. They don't even think about it. Well, as long as we're using derived class objects in situations where base class objects are expected, well, that's cool. That's the way object-oriented is supposed to work, but it actually is not working as well as we would like from a maintenance point of view. So here, draw is no longer polymorphic. It's a normal function. And what it does is it calls setup, and then it calls an abstract method called render. Now, the render here could legitimately be protected. This is the one situation where I will use the protected keyword. I never use it on fields, but I will use it here. And that's because I don't want anybody to call render who is not an extension, who is not a derived class. Render should only be called by subclasses. So that's what protected is for. And it's not really calling render, it's overriding render, right? So to override render, it has to either be public or protected. It can't be private. So there we are. So is everyone following what I'm doing here? So your old draw function is going to have to be renamed render. And setup can now be made private, which means that you'll get compiler errors in all the old draw functions if all you do is rename them. But that's okay, right? It's a legitimate bug. You want to fix it. And the solution is delete the line that says setup. So now the line has a single responsibility, another one of those solid principles. The line's single responsibility now is to draw itself. And we have eliminated the secondary responsibility, which was to set up the graphics. That responsibility has been moved into the class that has the information that it needs to set up the graphics, the base class. Is everyone with me? So what we have here then is a situation where we have eliminated the getters and setters. We have eliminated a lot of the polymorphism. We've eliminated the complexity, at least in terms of eliminating the complexity at the line and the circle level, which is where we really care about. We have eliminated, we've made this better in many, many ways, and we've done that by eliminating the get and set methods. Everyone with me here? So getters and setters, it's not that they're evil, or if they are evil, they're evil because they're adding unnecessary complexity, and they are damaging the flexibility of the system, which again, from an Agile point of view, is a horrible crime, is that we need to be able to modify things without worrying about those modifications rippling out into the rest of the world. And if we have getters and setters, we cannot do that. Is everyone understanding the point that I'm making? So the rule here is that we want to ask for help, not for information. Right? You look at simple things like a money class, right? It's got a value, it's got a get value, it's got a set value, but that just doesn't work. It really doesn't work, right? There's a lot of issues here, but imagine that what we want to do is we want to add a currency. Well, I guess I could have, in other words, here what I want to do is, first of all, if I don't have a currency, I want to check two values against each other, and I have this code with the getters and setters. But first of all, that's an awful lot of code, even now. But if I want to add a currency, I get this hideousness. Right? In other words, if I had a get currency and a set currency, I'd end up somewhere like this. And this is obviously unacceptable. Right? Because I have to do this everywhere I compare two values, everywhere in my program. Talk about a maintenance nightmare. So this is where the getters and setters strategy has gotten me, to the point where I have an enormous amount of work that's happening outside of the class that contains the information, and that work is happening in 1,000 places. Does everyone see the problem? The getter and setter is not helping. The getter and setter is adding a vast amount of complexity to the program. So the question is, how do we get rid of it? Well, what if we move into the money class the code that we need to actually do the work? Right? In other words, here's what I want at the higher level, at the user level. But if you look at money, if money implements a larger than, then all of that currency computation can happen inside the money class. And I don't need the getter and setter anymore. I don't need get value, and I don't need get currency, because money is comparing itself against another unit of money, and it doesn't have to get anything. Right? Now, if I add currency at this level, in other words, the changes are limited in scope to the money class. Now, I'll have to add a few other methods of the same sort, but that's fine. Now, the other thing to notice as we move forward here is that notice that the methods that I've added are all methods that make sense in the domain level. Add a unit of money to another unit of money. Add money together. Right? That's something that would make sense to any accountant in the world, right? I want to add $10 to $20. I want to add 10 pounds to 20 pounds. While get value, set value makes no sense to an accountant. I'm way out of the domain now. So by working this way, I'm also keeping things closer to the problem domain. All right? Same things happen with stuff like strings and properties, right? Imagine if I use properties here. This code scares me. Right? These methods throw exceptions. This could crash the server. So I have code that looks like I'm accessing a field. Is everyone following me here? MyProp, x.myprop. And it crashes the server. If you're not scared by that, then you're not thinking. So is everyone following what I'm getting at here? So we have a situation then where if the property is a simple property that is not doing nothing but returning a value and setting a value, it's nothing but a getter or setter, and we're back where we started. We haven't gained anything. And if the property is doing more than simply setting or getting the value, it's dangerous. It's introducing subtle, potentially severe bugs to our code that are going to be difficult to think about, much less test. So if getters and setters are bad, properties are even worse. Is everyone following me here? So the reason I'm saying this is that amongst many of the Microsoft programmers that I've worked with, they'll put a class together, and the first instinctive move is put properties around all the fields. In fact, some of the automated tools that we use to put things together or analyze code, even ReSharper, right, will complain if the properties don't exist. And I'm suggesting respectfully that properties are bad. You don't want them. For the same reason you don't want the gets and sets. They're making the code more complicated. They're allowing you to have bad structure where you are getting stuff and doing work in doing the same work in multiple places rather than putting all of that work into one place inside the class where it belongs. It's really bad design by just about every measure. Now, of course, if you're programming in the Microsoft world, at some levels, you don't have any choice, right? A lot of the libraries require you to have the properties there, so do that. Right? I'm perfectly pragmatic. I'm not going to argue that you should throw away everything that you're working on because there's some theoretical notion that properties are bad. But what I am saying is that use them where you need to use them and don't use them anywhere else. Don't use them just as an automatic automatic thing every time you put a class definition together. Okay? So getters or setters or equals. We've talked about all of these reasons, so I'm going to go through them very quickly. Bang. Now, the other problem with this is that notions like draw yourself are not really practical solutions here, right? Because you can't keep modifying classes to do everything that they need to do and end up with the class being maintainable. Or put it another way, if all of the data stays inside the class, and if every time you need that data to be manipulated, you delegate to the class, that means you've got to delegate for everything, including stuff like rendering. Okay, at least theoretically, but practically speaking, that's not a solution because you don't want to be forced to modify the base class every time you need to add a capability. That is the open-closed principle that we were looking at yesterday. So we'll solve that using, in this case, a design pattern, which is called builder. All right? So the issue with a builder is that a builder is taking onto itself a task that could be done elsewhere, but in this case isn't. The builder is tightly coupled to what's called the director in the design pattern. The builder, which we'll look at in a second, knows a lot about what's happening inside an employee. And that's actually okay. In other words, you can think of the employee class as having two categories of interfaces. One of them are outward-facing interfaces that everybody else in the program is expected to use. And in this case, we have an inward-facing interface. It's an interface that I'm exposing to a helper class, and I'm not exposing to anyone else. Unfortunately, there is no syntactic mechanism in any language that I use, at least, that allows me to express that, not that concept in the source code. So I just have to comment it or use a naming convention. Right? In Java, you can do class access, but that's not really what I'm asking for here. In other words, what I want to say is I am implementing interface X, and only the following classes are allowed to use interface X, but nobody else can. Right? And package access is kind of like that, but not really. So let's look at it. An employee could generate a representation of itself, but again, it might have to generate a dozen of them. SQL representation, XML representation, a JSON representation, a widget representation, an HTML representation. The list is endless. And I don't want to put all that code in the employee. So what I'm going to do is I'm going to say when the employee needs to build a representation of itself, you'll call export. And what you'll pass in is an instance of something that implements this builder, or in this case, exporter interface. All right, so everyone with me here. And there will be many implementers. Now, in a sense, though, if you think about what that exporter looks like, export name, how's that different than get name or set name? Right? In other words, the builders can go in both directions. I can have an importer that imports things into constructors also. Right? How's that different than a get set? And the answer is that it isn't, except in one important way. And that important way is that when I'm maintaining this code, I know that if I change the employee class in such a way that I have to change the interface, I know exactly where to look in order to maintain that. Not only do I know where to look, but the compiler will tell me where to look. Because if I change the interface, then the implementations will now be incorrect. Is everyone with me here? If I have generic getters and setters that are open to anybody, I don't have that advantage. I have no help from the compiler, and anybody in the program could be using the getter and setter. So I haven't eliminated the need for an accessor or a mutator here, but what I've done is I've controlled it. It's very tightly constrained. And I've set things up so that if I need to make a change, the compiler will help me. And if I had a generic getter or setter, that would not be the case. All right, so using this is pretty straightforward. If I want to export to JSON, or I import from JSON, here I'm importing, I pass an importer into the employee, and the employee will pull its initial values out of the importer. Is everyone with me here? So here I'm importing from JSON. If I wanted to import from a database, I just change the importer type. I don't change the employee, which is kind of interesting. So here we have a situation now where the employee can initialize itself from any data source, provided that I have an importer customized for that data source. That's pretty useful. The employee is initializing itself. I don't have, somebody asked the other day about a constructor that has 1,000 arguments in it. I don't have that here. The constructor has one argument in it. It's got the importer. So is everyone with me here? Same thing on exporting. I want to export to HTML. What will happen is the employee will push into the exporter all the information needed to generate an HTML representation. If I want to import to something else, JSON, I just change the exporter to a different kind of exporter. The employee doesn't care. It pushes into the new exporter the information that it would otherwise be pushing. Go to a database, same thing, just a different exporter. I do not have to modify the employee class at all. Notice that the employee class is now isolated completely from the database. That's a really good thing. Notice also the employee is isolated from the UI, which is also a good thing. Right? Is everyone following what I'm getting at here? Another one, a widget. So the implementation of this is what you would expect, right? Here's the import side, or here's the export side, rather, where I have an employee and it's got an exporter interface and an export method that just pushes to the exporter. And then on the import side, here I've got an importer interface and constructors that do nothing but pull from the importer. And I only need the one constructor with the one argument. If I want to build something, here's a kind of brain-dead simple way of building HTML, is that you can argue with me. Actually, you wouldn't be an argument. I will happily admit that this is not the best way to do this, but it's the shortest way to do this, right? So there's no argument involved. This is not great code, but it does make my point, right? Which is that here's a simple exporter where all of the HTML stuff is hidden. The employee doesn't have to know about any of this. Pushes information into the exporter builds the HTML. So everyone following me here? Here's an importer that reads information from the form data that comes back up from the client. Since the exporter produced the form, the exporter has created all of the IDs that the importer uses to get the data back. And there are a bunch of design patterns here. Those of you that did the design pattern class on Tuesday will see some of them, right? Is that we have chain of responsibility, we have certainly all of the delegation-related problems are here, right? But here's a UI architecture that is not model view controller. But it works really well. In other words, the way this is going to work is let's say you want to build up a simple form on a web page. You create the 3 or 4 objects that will be represented on that page, and you say to each of them, export some HTML that represents yourself using this exporter, and you take the results of that and put it together onto your web page, onto your generated page. You send that down to the client. Your user fills out the form. They hit submit. Form data comes back up. And then the servlet, or whatever it is that's service, or whatever it's handling the form data on your end, gets those same 3 objects that participated to the original form. And it says to those 3 objects, import into yourself that part of this form data which is interesting to you. Right? The service doesn't know anything about what's actually happening. That's all happening inside the objects that created the data. In other words, the object that created the data is responsible for pulling out the new value. It's not a controller in the model view controller sense, because it doesn't know anything about the objects that are pulling the data out of the form. All that it's doing is it's routing the form data to the 3 objects that were involved. It is an instance of the mediator pattern, but this is not model view controller we're talking about. Completely different architecture. And I would argue it's more maintainable than model view controller is. This is one of many alternatives. Of course, if you go this way, you don't have all the MVC framework stuff to help you build code that you have now. Right? So the downside of going to this kind of design is that you have to just not use some of the frameworks or some of the class libraries that you're used to using. And one of the decisions you're going to have to make as an architect is whether that's the right decision or not. In other words, there are advantages to go to a going to a theoretically better architecture, but there are also real advantages to using libraries that you have at your disposal. So that's a decision you have to make as an architect. I'm not going to claim that either one is better or worse. It's that there's good reasons to go both ways. Okay? Questions? So the main thing that this means is that objects are defined by what they do, not by what they contain. This notion of designing by responsibility. That you have to ask yourself, what is the responsibility of the object? And then you implement those responsibilities, and you implement them in such a way that there is no knowledge outside of the current class as to how those responsibilities are implemented. And if you do that, as we just saw, you end up without things like getters and setters in your code. But what we haven't seen yet, which is the next topic, is how to get from point A to point B, is how do you get to a design where everything is done by responsibility and the getters and setters aren't there simply because they never come up. The need for them never arises. Okay? So to do that, I'm going to make this blank for a second and go to a different slide deck. This is from a much longer talk that I do on design, is that one of the, I do a long series of talks, which when I do this in-house for companies, this class could extend, I can cover it in a morning, and I actually do that sometimes, it's half-day classes. But this could also be a week-long hands-on seminar/exercise, which is by far the best way to do it, is that what I'm going to talk about then is not Agile in general now, but just the core process, the core of the core process, is how do you get from point A to point B? How do you get from the notion of a story to code? And what I'm leaving out, just so that you know what I've left out so you know what to research, how do you write a good story? You know, how do you talk to users and come up with a story that's viable? How do you do planning around those stories? How do you prioritize them? How do you decide what to work on? How do you size them so that you can implement the story in the course of a week, right? This is all having to do with Agile, but of course in this class we don't have time to talk about all of those topics. So I'm going to focus on the one thing that's most important in terms of the current context, which is how do you start out inside an Agile process with artifacts that are naturally part of the Agile process, in this case the stories, and end up with code that looks like the code that we've been looking at. Okay, but there are a few Agile principles that are important. The first one is there is no such thing as requirements. Oops, stop. Oh, we get to see that twice because I accidentally clicked my button. Oh well, I love Keynote. Anyway, so the issue here is that basic issue of an Agile system is you don't know what a program should do until you do it, until you use it. That's one of the basic tenets, is that you can ask people what they want until you're blue, and they don't know. And the reason they don't know is because they don't have anything tangible in front of them. They can't tell what's good, they can't tell what's bad, they can't tell they can't remember what they've forgotten. Right? Upfront requirements gathering doesn't work. So instead of saying, what should this program look like? That's a question that you as an Agile designer will never ask an end user. What should this look like? You shouldn't even ask them the question, what should this do? The question you ask them is, what are you doing? What problem are you trying to solve? And if the computer program didn't exist, how would you go about solving it? You're not in the realm of computing here at all. In a sense, you are designing a computer program, but from the user's perspective, you're not. You're not asking questions about dialog boxes and drop-downs and buttons and showing them mock-ups of UIs and that kind of stuff. You're saying, what problem are you trying to solve, and how would you solve that? And if they can't come up with an answer to those two questions, you should just all go home. If there's no problem to solve, why waste 6 months not solving a problem? Or solving the wrong problem? Right? So that's fundamental to Agile, is that Agile processes tend to generate programs that actually do something useful, because we'll start trying to identify the useful thing they have to do, and if we can't identify anything useful for them to do, we have nothing else to do. We all go home. All right? The other issue to bear in mind is that these requirements are going to be changing constantly. So an Agile system, then, is really a continuously evolving prototype. It's not a mock-up, it's a prototype. Right? A mock-up is something that's fake, something you build in a mock-up tool of some sort. A prototype is a fully functioning thing that may or may not have all the features that you want. Some of the features it might have might turn out to be wrong. Maybe the engine on this airplane turns out to be inadequate. We've got to swap it out for a different engine. Is everyone following me here? But the prototype is a real airplane. If you think about the actual literal meaning of the word prototype, it's just the first one, right? Is that once the prototype gets good enough, we'll just make the exact copies of it. So all Agile systems, we're never going to mock up anything. Or if we do mock it up, we're going to mock it up in the easiest way possible. We'll do the closest thing to no work that we can get away with. If we're doing a UI, we'll mock it up just by quickly drawing sketches on a whiteboard and then snapping pictures of them with our cell phones. We're not going to mock them up in some elaborate tool. Okay, is everyone with me here? And then the other concept is this notion of continuous delivery or continuous development, where stories are going into this pipeline, and then releases are coming out of the pipeline at a regular pace that's got something to do with the stories. And then customer feedback is going into the pipeline. So customer feedback is informing the set of stories that we're working on and the set of releases that come out of the other end. And it's a continuous process. It just goes on like this pretty much forever until there's no more stories, in which case the program is finished. So it's a continuous process. It is not a staged process. So at the center of it then is this notion of the story, right? The story is at the center of the Agile universe. And the story then is a story. It is something that is describing the user solving a problem, written entirely in the domain of the problem. It is not a description of a feature in a computer program. Is everyone following the distinction I'm trying to make? It's an extremely important one. So stories have to have some characteristics. They have to be testable in the sense that you have to be able to make an acceptance test to make sure that the story has been implemented properly, at least one acceptance test. And this could often be a whole suite of tests, right? Is that you have to, you might have UI-based stuff based on any of the UI robot kinds of tools, right? You might have to, you might be testing with unit tests, of course. Well, of course you'll be testing with unit tests. There might be automated tests on interfaces that are used to go back and forth between the client server. Everything has to be testable, though. You have to be able to tell whether you're done. It's got to be very definite, in other words. There have to be indicators of progress in the sense that you look at what you've finished in the last couple days and you go, oh, that's about a third of the things that I need to do in order to finish the story, so I'm on track. They have to be small enough to be implementable quickly. Is the usual iteration time, the usual cycle time in an Agile shop is 2 weeks. So ideally then, all of your stories should be implementable in 2 weeks. If they're too big, you have to make them smaller. I'm not going to talk a lot about how to do that here. I'll talk a little bit about it. But that's a skill that you learn as you become Agile. You have to be able to roughly estimate them. Right? Estimation is not a big part of Agile. Time is not a part of Agile at all. Any Agile methodology that's functional is that you're never setting a deadline. You're never guaranteeing or even guessing that you'll have X done by this date. Because you can't, is that everything's flexible. The requirements are changing all the time. If the requirements change halfway through implementing something, then your estimates are all shot. So you can't commit to estimates. But in order to plan, you've got to have a rough notion of how long it's going to take to do stuff. Is everyone following me here? So people who are Agile, when they estimate stuff, they don't do it by time, they do it by things like story points, which are an indication of difficulty. And of course, the more difficult it is, probably the longer it's going to take, but there's no one-to-one. There's no, well, if it's got 3 story points, it will take a week, and if it's got 4 story points, it'll take 2 weeks, and if it's got 1 story point, it'll take half a day. That's incorrect. That is a fundamentally incorrect use of the notion of story points. Rather, if I have to redo the whole database, well, that's hard. So that's 4 points. I don't know how long it's going to take. I don't care. I just want to know whether it's hard. A lot of people recommend something called T-shirt sizing, small, medium, and large. I actually prefer easy, hard, and somewhere in the middle. And if you wanted to go beyond that to talk to management, there's also the impossible category. Okay? Stories are narratives, and that's important. On the left here, we have a narrative. We have Moby Dick. On the right here, we have the way that stories are represented in shops that are not doing things right. It's the narrative that we need. We lose too much information in this Scrum format sentence. As an X, I need Y to do Z. That is not adequate. That is not a story. That is only one sentence, and it's not a very good sentence at that. More to the point, it's not describing a problem, really, because all too often, this form is used to describe a feature request. In other words, I see things like, as a user, I need this button in order to do X. That's not a story. The story would be describing what you're doing where that button or whatever that button is supposed to do would be a useful thing. And maybe adding a button is the right solution to that problem, and maybe it's not, but we are in no position to make that decision until we know what you're trying to accomplish. The story is describing what you're trying to accomplish and how you would go about accomplishing it. Okay? So you start off then, in order to put the stories together, by coming up with this thing called a problem statement. And a problem statement, problem statements could go out to a couple pages, three pages. It's back in the days when we did upfront design. A full-blown problem statement for a program might be 80 pages long. And maybe after you've been doing this for a year, your amalgam problem statement would be that long. But in Agile, we're not, of course, going to try and do an 80-page problem statement before we do anything. We're going to try and write down in English or whatever language is the native language of the developers, or of the users. It's actually the users that we care about, what problem they're trying to solve. And notice here, as you skim through this, I am describing a problem from the perspective of my customer. I'm not describing a computer program here. I'm talking about tech support customers. I'm talking about the techs. I'm talking about collecting customer data, whatever that is. But these are all things that the guys in tech support care about. This has got nothing to do with the computer program. Okay, is everyone with me here? All right, now, once we get the problem statement is giving us two things. It's giving us focus, and it's giving us a notion of what the classes in the system have to be. Is that my feeling is that the vast majority of the classes in the system, and in fact all of them if possible, should have names that are nouns in this problem statement someplace. Now there will be implementation level classes, of course, that don't follow that rule, but I'm talking about the policy layer, right? The place where we're at the top of the program, the stuff that's closest to the user interface. So again, getting to a concept that I was talking about the other day, what we're trying to do here is to keep a one-to-one relationship between the code and the user's notion of the problem they're trying to solve. And the reason that we're doing that is that over time, what's going to change is this problem statement. And if all of the concepts, the hard concepts, hard in the hard versus soft concept, in the problem statement are represented by classes whose names are the same names that we're using here, as this changes, we know exactly what needs to change in the code. Changes become much easier. And that's fundamental in any kind of Agile development, is this notion of change is expected, it's welcomed, in fact, and that when a change comes along at the user level, the code must be changed in order to accommodate that new need as quickly as possible. And so the question is, how do we structure the code in order to make it be easy and quick? And the best way that I know is to have this one-to-one relationship, is to, if there is in this case, I look at this and there's a tech support customer is a possible class. A tech is a class. There's some customer data here maybe, or a customer profile. That's actually the proper class, is a customer profile. We've seen some information about what has to be in the profile. A problem is probably a class. I probably want to keep track of what the problems are. The tech who answers the phone, that's telling me I've got to somehow keep track of the connection between the techs and the problems and the customers. There's some sort of relationship there that has to be maintained within the system. So everyone's seeing what I'm doing here as I'm looking through this. This is a design. This is not just a exercise. This is a design that I'm looking at. So is everyone with me here? Right? When you read the Agile books, they call this the system metaphor. But I don't think that's a useful term, is that people don't know what the word metaphor means. Right? But when they're talking about the system metaphor, this is what they're talking about, is a problem statement. Okay, questions? So this is a part of our design process then. And what we're looking at here is not, again, a domain level statement, though it is. We're looking at the code too. This is a window into the finished program. We're not drawing any UML or anything like that unless we feel like it. We can, but there's no requirement that you do that. If it's simple enough, you can just keep it in your head, or you can just write it down in code. I could stub out the classes, for example, in C#. But you have to do this. So this is a system metaphor then. It's a conceptual framework on which the whole structure of the program is going to be hung. And it's something that everybody can understand. Remember, Agile teams are multidisciplinary, or they should be. So you look at who's in the room when the team gets together. And there are some coders, and there are some UI guys, and there are some business people, and there are some end users. And I should say one of the things that I think of as wrong in Scrum, and I will use the word wrong here, is the notion of a product owner, which is an inside person who serves as a surrogate for the user, is, I think, fundamentally flawed. At least I have never seen that succeed. Is that you need a user. You don't need somebody who imagines that they're a user. You need a user. They have to be there in the room, at least virtually, right? If you can't get together physically, but they've got to be there. All right, is everyone following me here? Which means that if you're producing artifacts, they've got to be artifacts that everybody on the team understands. And a problem statement is that. It's an artifact that everybody on the team can understand. It's a conceptual framework that everybody is on the same page with. We all understand what we're doing here. We're all going to be moving in the same direction. All right? It's also based on the domain. It's based on the customer's mental model, not yours. Because programmers immediately go towards implementation, and customers will not understand that. So we lose the advantage of having a common metaphor that we're all on top of, that we're all working with. So you want to stay out of implementation as quickly as possible, or as long as possible, rather. Okay? It is not a description of a computer program, ever. It's a description of the user and the user's problems. So the next order of business is we start writing out the stories. And the one that I like to start out with is the thing that I call the happy path. The story where everything just works perfectly. Everybody is happy. The fairy tale world where we all wish we lived. Right? Everything works perfectly. The customer calls in, a tier 1 tech creates a new profile, so on and so forth. Right? And notice again, this is a narrative. This is not a, I need X, as a tech, I need X to do Y, right? This is a little narrative. It all fits on an index card. This is kind of long, but I'll address that issue in a moment. All right, so everyone following me here. If it does not fit on an index card, it's too long. You'll have to break things up into smaller stories. Does everyone just skimming through this, though, get a feel for what this is like, though? Again, it's a narrative. And I'm capturing useful information here, right, is that hardware configuration, and then I list what I want. You know, there's more detail here than there was in the problem statement, maybe. But this is the unit that implementers will implement from. Now, I can now narrow the story. I can say that was too big, let's make it smaller. So let's take out the notion of I'm just contacting you and there will be no follow-up, with a story where there was a follow-up, there was a second contact. So now they each fit on half a card. I'm happier. That's going to fit into my 2-week cycle a little bit better. It's the same story that we had earlier. I've just broken it up into smaller chunks because it's a little too long. All right, so everyone with me here. Now I should say, by the way, these stories, if I had been teaching this class 10 years ago, I would call these use case scenarios. And one of the characteristics of a use case is that a use case has to have a useful outcome. At the end of it, you have to have achieved something real. So when I think of stories, I think, well, I can split a story up horizontally or vertically. And the difference is the original story had a starting point at the top and a useful outcome at the bottom. If I split it up horizontally, I haven't achieved my outcome yet, and that's not valuable. So when you're splitting stories, you split them vertically. All of the sub-stories should arrive at the same useful outcome, but we're leaving some of the details out that you would use to get there, as we're eliminating some of the complexity. They are simplifying. We're not breaking it up into part 1, part 2, part 3. Rather, we're taking the big thing and making it simpler so that it can be smaller. So instead of thinking one big complicated thing with lots of if statements, we'll have 3 or 4 simple things with no if statements. And if there ends up being some overlap, well, that's fine. That's just less work to do. All right, so I think of this then as a narrowing process rather than a splitting process. So I'm taking a wide story with a lot of details and making it narrower in scope. Now we can start thinking about follow-up stories, right? I have to hand things off to Tier 2 tech support. Okay? And again, this is still a narrative. But now I'm leveraging the work I've already done. It's like the Happy Path story, except. So in terms of priorities, remember I was talking about in Agile, everything's done on a priority basis. This is going to have to be a little bit lower priority than the Happy Path story because it's depending on the Happy Path story. There's a dependency relationship there. One of the things that you can do as an exercise, which is kind of interesting, is to take all the stories and just tack the cards up on a big bulletin board, or on a whiteboard, but is better still, and then just draw arrows showing the dependency, right? This depends on that. I point at the things that I'm depending on. The things with the most number of arrows pointing into them, those are probably the things you want to do first. The things that everybody else depends on. And it's a complicated mesh. It's not a simple tree, usually. So there's a lot of judgment calls here about what you want to do first. Okay? Is everyone with me here so far about how this is working? So the next thing we do is we look at these cards and we say, okay, who are the actors in the card? Who's doing things? It's important to distinguish between actors and roles, right? Is that David Tennant is the actor. The role is Hamlet. Or to put it another way, the fact that you're a manager doesn't mean squat if all that I care about is the fact that you fill out timesheets. Is that as far as I'm concerned, you're a timesheet authorizer. It's the role that we care about, not the actor. Or to put it another way, the actor is the guy outside the program, or rather the person is the guy outside the program, the actor, if you will. And the role is the thing that's inside the program. All right, is everyone with me here? So we need to identify our actors. And we need to decide what their responsibilities are. So that gets us to this thing called a CRC card. We have a class of roles, really. Somebody in the role of employee. So that's what the first C is, the class name, the role. So maybe they should be RRC cards. The second thing we have are the responsibilities. Exactly what do actors in this role do? So everyone with me? And then we have the collaborators, and who do they have to talk to in order to do that? Now notice I'm still at the story level. This is just an analysis of the story level. It's an analysis of the problem statement and the stories. I'm still not well, I am talking about computer programs. I'm designing classes here. But everything is still staying at the domain level. Okay? This is making sense to everyone. So you'll come up with a stack of CRC cards then that represent the roles that are involved in the stories and what the responsibilities are of the people in those roles in the context of the story. This changes over time, and that's fine. It was kind of subtle, but I just added another collaborator here when I clicked the clicker. Right? And the set of responsibilities might change over time, and that's fine. This is one of the big differences, again, between Agile design and normal design, or normal design, non-Agile design, whatever the opposite of Agile is. I need a good word for that. is that things change. You expect it. It's not a problem. Nothing is bolted in concrete. You should write these things out in pencil, not in pen. Now, there will be several CRC cards then, one for each role in the system. Now, the original CRC card exercise was kind of interesting, and we don't have to actually do this physically, but we should be doing this mentally, is that what they then did is solve the problem, work through a story by having a conversation. So you would create the CRC cards first, decide on the story you want to do, and then if you want to play it out, and sometimes I found this to be sometimes valuable in a classroom situation, sometimes not. The real world, you never do this, is that you just do it by sitting around a table talking about it. But you assign roles to individual people, is that in a classroom, you'd actually hand out the CRC cards to people. Here's your role. What you can do is one of your responsibilities. That's it. If you can't do something, you've got to delegate to one of your collaborators. And you can only talk to your collaborators. Those are the ground rules. The other rule is the object-oriented one. You can't ask for information. Okay, so as you set those ground rules up, the card is effectively a class definition. The human being is effectively an object. If there were multiple objects in a given class, you'd have to have multiple people all sharing the same card. And then you start working through the story. You just start solving things. You solve the problem by talking to other people. And as you do that, you find out that there are responsibilities that are missing. There are responsibilities that are perhaps never exercised. You would eliminate those. There are collaborators that are not on the list and should be. There are collaborators you end up never talking to, and those should be erased. So what we're doing now is making the cards very concrete in the sense of, by the time we're done, there will be no responsibility on any card which is not needed for implementing this story, and there will be no collaborator who I don't actually talk to, and every collaborator who I do talk to will be there. So everyone with me here? Now that's just for one story, of course. If we're going to recycle these cards for the next story, we'll start adding additional responsibilities as is required for the next story. But we've got to start somewhere, so we'll start with the first one. The cards will change. That's important. This is why we're doing this. Okay? So what have we done here? We've actually done two things. We've built both a static and a dynamic model, if we want to use traditional design terms. The static model is your class diagram, and that's our set of CRC cards. The dynamic model is interesting here. If you take a tape recorder and you turn it on while the conversation that solves the story is happening, that is your dynamic model in the sense that every request, every sentence, everything that's said in the process of doing that story, that is a message in some class. So what we've just done is we've designed the complete set of public methods of the classes. We're not trying to guess what those methods are. We're not trying to say, well, this class, clearly we're going to have to ask it to do such and such. If the method doesn't represent a sentence that actually was uttered in the course of doing this exercise, it should not exist. So we have a minimal class. We have a class that has in it nothing but the set of methods that implement the requests and so forth that were part of the working out of the story. Is everyone following me here? So we actually have an object-oriented design at this point. And in fact, if you want to look at the static model, I usually just do this. I don't make a UML diagram anymore. I just stick them up on a tack board and connect between collaborators with pieces of yarn. You know, if you wanted to do cardinality, sometimes I put cardinality down here just by putting numbers and stars and stuff next to the thumbtacks. This is a UML diagram, actually. It's just a very flexible one, and it's one where I don't have to waste time copying junk into drawing programs and case tools and that kind of stuff. I've got the cards, I just stick them up on a tack board. I could convert it to UML, I suppose, if I wanted to, right? Is that it's a one-to-one, so it doesn't matter. But I usually don't bother, because the TAC board is adequate. The other thing that's nice about this is that the TAC board is up in the lab where everybody's working, right? The class diagram is out in the open where you can see it. I'm not a big fan of electronic design tools because it hides the design inside the computer. And I find that when you're working, if you have the design actually literally in front of you, it's more helpful. So I like the idea of having as much of the design as you have, literally physically out in the open where people are working so that you can see it. And if you need to make a change, somebody walks over to that board and starts shuffling things around, I can guarantee you that every eye in the room is going to move over there, right? And if he does something that somebody is annoyed about, there will be a discussion right then. You're not going to schedule a meeting, right? There aren't many meetings in the Agile world. There's plenty of discussion, but there aren't many meetings. Why did you just do that? You cannot do that, I'm sorry. You know, and then you talk it through, right? So you think about a normal shop where there's meetings not scheduled for next week, so we got to work, so we'll just do it, and then we try and do a check-in, and we can't because there's all these conflicts, and then you start trying to resolve the conflicts, and somebody has made this wacko change that's broken everything that you're working on, and this is really, really, really not very productive. On the other hand, if I walk over to this board and start shuffling cards around, and somebody says, no, you can't do that, and then you say, okay, well, what can we do here? Here's my problem. And you explain your problem, and we'll figure out how to make it work. That solves all those issues. You don't end up with conflicts because you've resolved the issues ahead of time. You are designing. You're just designing incrementally as the software is evolving. Right? Is everyone understanding what I'm saying? The other important thing to notice here, though, is that we have maintained that one-to-one relationship to the customer's notion of the system. And the other thing to notice is there are no getter and setter methods here. There isn't even any derivation because we don't need it. It doesn't arise. And we're going to implement exactly what we're designing. We're not going to make stuff up as we turn it into C#. We're going to implement what we're designing. It's a very flexible design process, but it is a design process. It's highly disciplined, very informal, highly disciplined. Anybody that thinks that Agile is undisciplined doesn't know what Agile is. Agile requires more self-discipline than any process that I know of. But it's self-discipline. It's not coming from outside. There's not a lot of paperwork that's forcing you to do things in certain ways. It all comes from knowing that you have to do things in the right ways or everything's going to turn into garbage. So we have a lot of discipline here. We have a direct connection with the end user. We don't have getters and setters because we don't need them. We're delegating everywhere. Everyone's seeing what I'm talking about here. So this is the issue of how you get from point A to point B, is this is how you make sure, this is how you write code in such a way that getters and setters aren't needed. You don't write a bunch of random stuff and try and get rid of them. That's hard. Because what you do is write the correct thing to begin with. But you don't design it all up front because that doesn't work in the Agile world. Is you focus on one story, you do a little work, you do a little design, you implement. Then you pull out the next story and modify. You can't modify unless you have unit tests in place. So there's a requirement that there be unit testing. All of the practices that comprise a solid Agile, a good solid Agile framework interact with each other in very complex ways. You can't do this unless the user's in the room because the questions that come up are questions that you need answers for right now. Not a week from now, not even an hour from now. You need them now. Because if you don't have the answer now, you'll make a decision and you've got a 50-50 chance of it being correct. And it's going to take a lot of time to back out an incorrect decision. On the other hand, if the user is sitting in the room with you, you don't have the problem. You ask the question, you get the answer, you move on. So again, this is requirements gathering. It's just that instead of doing requirements gathering for 3 months up front, we're doing requirements gathering on the fly as we're working. So what we have to have in the room are all the people that would be there when we were doing a formal requirements gathering phase in a traditional functional or procedural design process. All right, is everyone understanding what I'm getting at here? And the other thing to bear in mind here, which is important, but you wouldn't see it from the CRC cards, is that the static model, the CRC cards themselves, are really an artifact of the conversation. It's the conversation that's the important thing. Because the conversation is the code, right? That's who's talking to whom over the course of time as the program runs. And when the conversation requires us to change the cards, we do that. We don't ever say, well, I can't talk to you because you're not a collaborator. You say, I have to talk to you, so I guess you're now a collaborator. Does everyone see what I'm getting at here? So a lot of programmers want to go directly to the static model when they're programming. They want to design the class hierarchy before they start actually writing the methods. And what I'm saying is that according to this way of thinking about things, that's backwards. Is that what's driving things are the messages. What's driving things are the methods. And the class diagram is just a convenient way of keeping track of who's responsible for what and who says what to whom. Okay? Questions? So, you know, so the one conversation, or not conversation, the one huge criticism, and I wouldn't even call it a huge criticism, but the one criticism that people have about Agile when they talk about it is that they don't want to do Agile because it's a form of socialism. Living in the United States, that's actually trotted out as an evil. They equate socialism with evil in the United States, which is odd, but there it is. But in the interest of pursuing this notion of Agile being socialism, my conclusion is that we should all adapt it. We should all adopt it, right? In other words, it's actually, oops, what happened to Lennon there? He's disappeared. There he is. Is that it is a kind of socialism, if you will, in the sense that we're all working together socially in order to get this together. It's a collaborative process. And it's a collaborative process where everybody is benefiting and everybody's more or less equal in the process. Is that one of the things about the distribution of power within the team is there's no one team member that has more power than other team members. There's no manager. There's no project manager in an Agile system. Okay, but the basic idea here, I guess, is kind of socialist, but the real notion is that this is a collaborative process. Everybody's working together. Everybody carries equal weight. We have lots of different people with different skills that have to collaborate in order to make this work. And what we're trying to do is come up with a way of doing things where everybody who participates in that world can not only contribute up front, but can contribute through the whole process. So by keeping everything in the domain level, we achieve that. By having the user in the room with us, we achieve that. By coming up with a design that's directly reflecting the way that the end users think about the problem, we achieve that, because when the problem changes, it becomes very easy to change the code because we have that one-to-one connection between things. Okay? So, oops, where'd it go? There. Oops, I went the wrong way, sorry. We got to see London again. Now I'm probably going to skip past the question slide. Well, we can give up. I can just forget about my last slide, which just has a giant question mark on it. There it is. So, are there any questions?
So how does the requirements gathering process work when you're working on brownfield project situation, let's say not a business project, or
Well, what I would do, what I have done in that situation, is I start with, I do the stuff we're just talking about. And then I say, with the legacy code, I do two things. The first order of business is I try and break it up into standalone modules with well-defined interfaces between them. And then I try and identify stories which affect mostly one of those modules. And then I implement within that module, and since everybody's talking to me across a well-defined interface, they do not know that I'm modifying things inside the module, though you do have to sometimes go out and touch other pieces here and there. Insofar as it's possible, I take the business logic and concentrate it into helper classes, which I can use from the classes that I'm developing as I go through the story. And if it makes sense, I will refactor those things into the new classes. And that way, I'll just kind of gradually migrate into the new architecture. Before you can do any of that, you have to have unit tests in place. And you have to have acceptance tests in place, both. So the biggest problem that I find with making the sort of transition you're describing is that those kinds of systems tend to not have any unit tests or at all, and have only marginal acceptance tests. So there's always a week or two in there where we're just going to focus on testing. Before we do anything else, we're going to put tests in place, because it's very risky to start changing things if you don't have the tests in place. So testing is always the first step there. And the whole team, it's a good thing for the whole team to focus on writing the tests, because then they get familiar with pieces of the code that they might not have been familiar with before. But any time you're working with a legacy system, it's hard. But I'm not, I'm a practical guy, is that I will never say, throw it out and redo it from scratch. That's not going to work. So we need to migrate gradually in an orderly fashion. So like the last system I worked on, what we did is it was a big website, but it had financial stuff happening all over the site. And we took all of the financial stuff and concentrated it into a financial subsystem, provided a REST API for the financial subsystem, and then gradually rewrote the existing legacy code out of the financial subsystem to use the new interfaces. When we implemented the interfaces, I was doing it in a BDD style way. So I had mocks on both sides of the interfaces. I had mocks that were pretending to be the financial subsystem on one side, and on the other side I had mocks that were pretending to be the system that was using the financial subsystem. And that way I could get the finance guys working on their side of the interface and the other guys working on their side of the interface in parallel without getting in each other's way. And as long as the interface was working intelligently, then it was happy. So the first thing I had to validate was that my mocks were actually behaving intelligently, which took about 3 or 4 days. But once I had that, then I could have the two groups working, in parallel, and that was pretty viable. And you can take that logic and you can spread it out to 3 or 4 or 5 groups. So having well-defined interfaces is really an important part of that. The notion of working with business-driven development tools or test-driven development tools and mocking frameworks, and this was a C# project, so we were using MOQ, mock with a Q, as our mocking framework. But PowerMock and JMock and EasyMock and all those things in the Java world work really well. But you have to learn how to do that stuff. That's really kind of part of the whole Agile thing, because that's the way that you're working. The other thing that the mocking process gives you, which is very handy, is that if you write a set of interfaces and then you write a set of drivers for that, right? A set of mocks which are trying to accomplish something, trying to work through a story by calling methods of the interface, I guarantee you that you will find flaws in the interface very quickly. So this TDD, BDD approach is really a design mechanism. It's not a testing mechanism that you get these nice tests, but really I think of it as a design process, right? A process where you end up with changing the interfaces in order to accommodate the real needs of real code. So I just looked at my watch and we're like 5 minutes over at this point. So I'm happy to continue to answer questions, but I have to officially allow you to go. So, so thank you all for attending, and hopefully you got something valuable out of the session.